Hello everyone, welcome to the 8th week of Chaos Coding class. Last week we introduced different algorithm games you can play. And if you have any questions about the game or anything else we have talked about, please do so on Google Classroom. And if you have specific question, please do include screenshots and we'll do our best to answer you as soon as possible. All right? And today we'll talk about the following topics. We'll talk about binary language, decimal versus binary system, and we'll talk about how to convert binary to decimal. And also we'll do a makeup activity at the end.
All right, challenge. Up to what number can you count using one hand? Pause the video and think about how many numbers you can count with one hand and come back once you have an answer. A lot of you might have said 5, right? 1, 2, 3, 4, 5. That makes sense. But through this lesson, hopefully everyone who's watching this video will learn how to count up to 31. Yeah, without cheating. So binary language. As you can see, you see a bunch of zeros and ones, and yes, that's binary. We might have covered it before, but today we're gonna go in a little bit more depth, okay? All right, think about videos, audios, or map, or any documents you have seen on your phone, your computer. Now, all those are written in zeros and ones, okay? All of them. It's fascinating, right? So all the files, all the data, picture data, audio data, video data, or text data, numerical data, all of them are written in binary code in computer and stored as binary code. Meaning, when we access them, we see them as videos, pictures, audio, text, numbers, but when it's stored, they're all stored in either zeros or ones, bunch of zeros and ones, okay? Yeah, so binary, what is it? It's a language the computer uses. So like the name suggests, bi means 2. So binary can have 2 values, either 0 or 1. Electronically, 0 means off, okay? 1 means on, okay? So the reason why they use binary is because it's reliable. So pause the video to think about why. Maybe you can go to the next slide and then you can think about why it might be reliable, okay? So let's talk about the difference between decimal and binary. Everyone in this room, hopefully, is familiar with decimal system. Now, you may not familiar with the name, the decimal system, but you know what it is, okay? So when I give you this number 109, right? Everyone should know that I'm talking about 109, right? So in decimal system, it's just normal, it's like normal number that we use, okay? Each placeholder can have 10 different values from 0 to 9, meaning in this, it can be 0 to 9, even though I wrote 9 as an example, it can be any number between 0 to 9, and even this position can have 0 to 9, here 0 to 9. And also each placeholder represent the power of 10, meaning the first position, it represents 10 to the 0th power, or ones. So we call this unit digit or ones digit. Now the second represents 10 to the first power, which is 10, meaning this is 10th digit. And this is 100th digit. So that means when you have 9 in the ones digit, we're talking about 9. But when you have 0 in 10th digit, that means we have 0 tenths. But when you have 1 in 100, that means we have 100. Therefore, we have 109, okay? Now you might be thinking, hey, isn't that obvious? Yes, it is obvious, yes. So there we go. Now let's go to binary system, okay? So remember this, each placeholder can have up to have 2 values, okay? Either 0 or 1. It cannot be 2 or 3, it has to be 0 or 1. Each placeholder represents the power of 2, and we call this bit, okay? So we have how many placeholders? We have 1 placeholder, 2, 3, so we call this 3-bit, okay? because there are three digits. Now we have the first digit, second, third. Notice that we start from 0, okay? So anyway, the first digit represents 2 to the 0 power, which means 1. The second one represents 2 to the first power, which is 2. And this third digit represents 2 to the second power, which is 4. So now, this means we have 1 ones, 0 twos, and we have 1 fours. Okay, so we have 1 here, 0 here, 4 here. So when you add them up, what do we get? We get 5. So number 5 is represented by 1, 0, 1 in binary system. Now, if you don't fully get that, I understand. We're going to do an example very soon. But let's think about why this is way more reliable than using decimal. And why can't we just use 5 instead of 101? And this is why. Now, you have seen the picture before in two slides here. The way that computers store data is not like our brain. Okay, maybe it is in a way, but it's stored in something called transistors. Okay, all these little dots are transistors. Okay, and transistors can have either 0 or 1, but in reality, it cannot be flat 0 or 1. So what we have is we have low voltage versus high voltage, where high voltage is usually about 5 volts. Okay, so the reason why using binary is useful is because the voltage in transistors may fluctuate. Okay, so for example, this low, this is supposed to be 0, but sometimes it can go up to maybe 1 volt. But computers, because it only uses binary system, that 1 voltage is also considered to be low. So that means even if it's 1 volt, it will consider that as 0 or off. Okay, so that's why binary is useful and reliable, because why? It ignores, or it's resilient to, electrical noise in the machine. Okay. Right. Anyway, moving on. Let's see how decimal system works. We have 42, right? So even though this is obvious, we want to go through this. Okay. So when we have 2 in this digit, this means 2 times 10 to the 0 power. Now remember, 10 to the 0 power is 1. So 2 times 1 is 2. Okay. Now when you have 4 in the 10th digit, that means 4 times 10 to the first power, which is 40. So we're just dissecting each digit in decimal system. And when we add them up, what do we get? Oh, I'm sorry. So that 0th digit represents the power here, exponent, and that first represents the first power. Okay, just keep that in mind. And when we add them up, we get 42. Okay, obvious, right? Now, another example, let's use a bigger number. Let's use this in binary system, okay? So let's say we have binary system. We have 1, 2, 3, 4, 5, 6. This is a 6-bit binary, okay? Because there's 6 digits, right? 0th digit, first digit, second, third, fourth, fifth. There's 6 digits total, okay? So what if we have 1 0 in binary system? Now, this is not decimal system, so do not say this is 10, okay? It's not 10, okay? It's 1 0, right? Actually, I was supposed to use like 0 0 0 0 1 0, but it's okay. But anyway, let's talk about this, okay? So we said each placeholder represents what? 2 to the exponent, right? So this digit represents 2 to the 0 power. This digit represents 2 to the first power, okay? 2 to the 0 power is 1. 2 to the first power is 2. But we have what? 0 of 1, right? So notice the exponents again. Yeah, too much animation maybe, I'm sorry. But when we multiply this, what do we get? 0 times 1 is 0. 1 times 2 is 2, okay? So does that mean 1 0 is 20? No, you have to add them up, okay? You have to add them up and we get 2. So in binary, 1 0 means what? 2, right? It's not 10. Do not read this as 10, okay? This is a binary system. let's make these things more complicated, okay? So let's say we have 001011. How can we convert this into binary decimal system? Because why? It's hard to understand for us. We understand decimal. Machines can understand binary. So we need to be able to convert one from the other, okay? So let's do this. So remember that the 0th digit is 0 to the first power, 0 to the 0, 2 to the 0 power, which is 1. The first digit is 2 to the first power, which is 2, and so on. Do you see that as you go more towards the left, the power of 2 is keep increasing. So you might want to remember 1, 2, 4, 8, 16, 32, okay? You have seen these numbers because if you look at your mobile phones or computers, usually your memory and your storage, they go by power of 2s. Maybe 64 gigabytes, you have 128 gigabytes, maybe you 256 gigabytes. It's not random numbers, it's a power of 2s, okay? But anyway, let's look at this. So when we have 1, that means it's on. When we have 0, it's off, okay? So let's do one by one. Right, so maybe the whole thing. So that 1 means what? It's on. This means on, off, right? So that means for the 1s, it's on, so you get 1. For the 2, it's on, so you get 2. For value of 4, it's 0, so it's off. So you don't get anything. For placement value of 8, or 2 to the 3rd power, it's on, so you get value 8. And the rest are zeros, so you get 0. When we add them up, what do we get? Oops, I'm sorry. When we add them up, what do we get? We get 11. So that means what? 001011 is 11 in our decimal system. Now let's do another example. By the way, if you get stuck, please rewatch the sections of the video, right? Because it does require some math, okay, and thinking. So let's do another example. Right? Example number 2. By the way, if you want to try on your own, pause the video and try it, okay? All right, now let's go over this. 110010. This is still 6-bit binary number, right? Just think of them as an on or off, okay? So on, off, right? So how many zeros do how many ones do we get? 0. How many twos we get? 2 and 1, right? So we get 2. 0, 0, 16, 32, right? So whenever it's on, you get that value, okay? Because the 5th digit or 6th digit was on, you get 32. And because the 5th digit was on, right, you get 16, and so on, right? When you add them up, you get 50. So 50 equals 110010. It's weird, right? But the reason why they use this instead of just 50 is because this is more reliable, okay? Hopefully I covered that part. Practice problems. Convert the following binary numbers into decimal numbers. Pause the video, try this. By the way, these are a 5-bit number system, okay? Let's go. Welcome back. Let's go to the solution. These are the solutions. So for the first one, let's go through it fast, okay? We have the first digit, right? The 0th digit on, so that means 1 times 2 to the 0 power, which is 1. Now we have 0th digit and the first digit on, so that means 2 to the first power is on, 2 to the 0 power is 1, is on, so 2 plus 1 is 3, so this is 3. And if you look at this one, the 0th digit is on, and the third digit is on, so 2 to the power of 3 and 2 to the 0 power of 0 is on, so you have 8 plus 1, which is 9. Now what about 1111? Now this is 31 because all of them are on. So it's like 16 is on, 8 is on, 4 is on, 2 is on, 1 is on, and 31 is the value. And guess what? That is how many numbers you can count with one hand.
Okay, if you don't have your phone or tablet yet, please bring them out. And once you're ready, let's go to learning. Learning, curriculum, as usual, and let's go. I'm the Fusion Maker. We did traffic light last time, so we'll start making smart street light today. We won't be finishing this week, but we'll get started. So what makes a street light smart? Well, there are two cases I can think of. The first one is where it's motion detection, where a light can turn on or off depending on presence of people or objects, motion. And another thing we can think of is where light turns on only when the surrounding becomes dark. And this week, we'll do the second version. We'll make light where it regulates itself depending on the brightness of the surrounding. So what do I need for today's make? You'll need the following items. So you're familiar with all these items except the last one being, so this is light intensity sensor where it can detect how dark or how bright outside is. And the top part is the one that can detect the brightness of outside. And we'll be using this to determine whether light should be turned on or off. All right, let's continue with circuitry. So even though we will not be making this today with Make-It, but if you do have Make-It already, feel free to try it out. So it's very simple. It's very similar to traffic light. So you will have LED lights connected at different locations in the digital output. And only difference is that we have the light intensity, right there. So just be careful that for ground, connected to one of the grounds. And for VCC, it is connected to 5 volts. And even though this is not very familiar, maybe just yet, but once you do this multiple times as the program goes, this will be more obvious and apparent to you, even without all this instruction. Okay, so feel free to follow this along if you want to, but for today, we'll just focus on block coding. Okay, let's move on. So let's read the instruction. Try coding pin number 10 as, okay, so what they're saying is pin number 10 is where LED light is, and it says turn it on when the intensity sensor is less than 300, but we'll change this number to maybe around 80, okay? All right, so you should be familiar with this. So you have when Arduino is turned on and forever, and remember when Arduino board is turned on, this is executed first and then goes to forever. So since we want to turn on the light only when the light intensity value is greater than 80, you want to make sure that LED light is turned off in the beginning. So pin number 10, brightness is 0, right? This means it's essentially turned off. So when you turn on the Arduino board, you want to make sure that the LED light is turned off in the beginning. Now, as soon as this is done, we need simple if-else statement that we learned. So there is if-else statement. If this is condition we have, and what we want is we want greater than, right? So if blank is greater than, well, we want this value to be 80, do not use 300, okay? And if you look for photoresistor sensor, so this is basically same as light intensity sensor. And we want to make this number 1. Okay, I'll tell you why it's going to be number 1, right? So basically what this is saying is, hey, if the value from the light intensity sensor is greater than 80, do the following. What's the following one? LED, you want to turn this on, right? So pin number 10, turn it on to 100. 255 is the maximum, but no need to go all the way to 255. This is bright enough. And we want to turn it off if it's not greater than 80. So 10 and brightness is 0. Okay. Now, normally what we do is we upload this to Arduino Uno. For today, for now, we'll do simulation. So if you don't have the kit, you can still do this. If you click this graph button, the simulated value for sensor will pop up. So this shows you how bright or how dark surrounding is. So let's dial up. And when it hits 80, you'll see the red light turns on, which is pin number 10. Now, do you remember that we use photoresistors number 1? The reason is because this sensor senses the darkness or brightness and sends it to, let's follow along the purple line, goes to A1. So this is the input. So if this happened in A0, we should have left it 0. So let's go back, stop simulation. Let's say we put this as 5, right? And then run simulation again. And see what happens. You'll see that nothing changes. Why? Because we said, hey, computer, read the value from pin number 5, but actually the hardware is connected to pin number 1. So when you're actually trying to build this or any project in the future and something doesn't work, one of the common things that you really want to make sure is you want to make sure whether your naked app and the hardware are matching with numbers. Are the pin numbers correct? Did we put the pin number in wrong number, wrong socket? Make sure you troubleshoot that first, okay? And for today, this is all we have. For your homework, this is what you want to do. The homework, I want you to do the rest of this lesson, okay? But here, you will be doing multiple things. For example, if you see this, depending on different values for photoresistor, you want to turn on or off different LEDs. Now the numbers 200, 100, please use different values. For example, maybe 60 here, maybe 40 here, so that it doesn't go over 100, okay? Next time, what we will do is we'll be actually making this project and run it together, okay? All right, thank you everyone. I really hope you have fun with this project, and I'll see you next week. All right, bye-bye.